Welcome to qnawire.
Chapter 16, Problem 106 from Chemistry, the Central Science. The question's asking, what is the pH of a solution that is 2.5 times 10 to the negative 9 molarity in NaOH? Does your answer make sense? What assumption do we normally make that is not invalid with this case? So whenever we are trying to find our pH and we're given a molarity of a molarity of an OH concentrations, the first thing that we're always going to do is just to find our pOH from that. So what we would do our pOH is equal to the negative log of our OH concentration. And whenever we do that, it's the negative log of the 2.5 times 10 to the negative 9. And when we plug that into our calculator, we get 8.6. So then to find our pH, we have to do 14 is equal to pH plus pOH. And so therefore it just ends up being 14 minus 8.6, and we get 5.4. But this answer is in the acidic area of our pH scale, because 0 is acidic, 7 is neutral, and 14 is basic. So it lies in the acidity area. And we know that NaOH is a very strong base. So if anything, it should be in closer to the basic area. So what we're assuming here is that, which is not valid, is that the concentration of the hydroxide ion is equal to the concentration of the sodium hydroxide. And so the first thing that we should automatically have noticed is that our concentration is very dilute. We have 2.5 times 10 to the negative 9 molars of NaOH. And so therefore, we are in a bunch of water. And so we need to be able to find our concentration of our hydroxide solution by adding the concentration of hydroxide solution of water with the hydroxide solution of NaOH. And that's because it is very dilute. So to do this, to find our pOH, we had to do our OH concentration. Our OH concentration is going to be your OH from your water in a dilute solution plus your OH from your base. And when you add them up together, you'll get a little bit stronger of a concentration. So our OH minus from the water is just going to be 10 times, it's going to be 1 times 10 to the negative 7. And then our OH concentration is what we are given. So when we add those two up, we get 1.025 times 10 to the negative 7. And then when we plug that into our negative log equation to find our pOH, we get 1.025 times 10 to the negative 7. We will get 6.99. And so when we do our pH plus pOH is equal to 14. 14 minus pOH will give us 7.01. And this is pretty neutral, but it's still more closer to the basic side than 5.4.